Now let us do average case analysis of binary search. So average case means total time taken in all possible cases divided by number of cases. So what are the cases? I may be searching for an element which is present here in the middle of a list or root of a tracing tree. So how many comparison it requires? Just one comparison required. Then next case is this one. I may be searching for 15 which is present here, which is in the middle of the left sublist, or 37 which is middle of the right sublist. So I may be searching this one or this one. So two cases. These two elements, how many comparisons required for these two elements? One comparison required for these elements. One comparison required. So I have included both 1 into 2. Then these four elements, how many comparisons required for each? 1, 2. For here also 1, 2. For this also 1, 2. So there are four elements which require two comparisons. Then 1, 2, 3, 4, 5, 6, 7, 8 elements which require three comparisons. So there are 8 elements which require three comparisons. So this is growing in the form. So for 15 elements we have taken an example, but we have to give it in terms of n elements, whatever the elements may be. So if we observe this, this can be written as 1 plus 1 into 2 power 1 plus 2 into 2 power 2 plus 3 into 2 power 3. So it is written in terms of powers of 2. Now this can be written as sum of I into 2 power I. So how I is taking the value? So here I is power 1, power 2, power 3. Just ignore this 1. So we can have a summation formula from these terms. So I starts from 1 to 3. So I start from 1. What is that 3? See, this is 1, 2, 3, 4. So this is height of a tree. Height of a tree. So height of a tree is measured by taking it just 1, 2, 3. So that is log of n. Log of n. So this is approximately log of n. So this log n is the height of a tree. So as many levels or whatever the height of the tree is, depending on that many terms we have to take. So here it is 1, then 2, then 3. So this is the total time taken in all possible cases. That is sum of the times taken in all possible cases. So I have taken the total number of comparisons required for searching each and every element. Then this should be divided by n, because total n elements are there. So that is the sum of all the possible cases divided by number of cases. So what is the case here? Each element is a case. Sum of the times of all the elements divided by number of elements. Then this numerator, this is approximately equal to log n. I is replaced with log n, and here also I is replaced with log n into 2 power log n, and this is divided by n. Then this can be written as log n, and this power n can be brought here. So this will be n log 2. So here we are taking the values in powers of 2. So that is log 2 base 2. So this becomes 1 and divided by n. So this is n gets cancelled. So the answer is n log n. So the average case analysis also log n. See, when we are finding average case, then we have to solve this one. Summation formula. Like I already told that finding average case analysis, finding average case results is time consuming. Sometime you cannot get the result, exact result. We have to take approximate one. If you want, you can convert this one into integration formula and you can apply the limits and get the result that approximately this will be log n into 2 power log n only. So average case time is also log n. So we have seen best case time is 1. Worst case time is log n, and average case time is also log n. Then we'll do some more analysis on this one. Let us do average case analysis for successful search as well as unsuccessful search. Successful search is if the element is found. So that is represented by these circular nodes. And unsuccessful search is element is not found. That is represented by these square nodes. For finding the average case time for successful search, we have to consider these internal nodes. The internal nodes require how many comparison? That depends on the level. 1 comparison for this, 2 comparison for this, 3 comparison for these elements. Depends on level. But here we can count edges, the path. See, this is 2 edges away from root. So to reach here, we require 3 comparison. So the path plus 1 we can say, path plus 1. So for every node we can take the path and plus 1. So for all the nodes we can take the paths of all circular nodes. So these circular nodes we can call them as internal nodes. So let us say I is the sum of the paths of all internal nodes. I represents sum of the paths of all internal nodes, which are representing successful search. Now these square nodes, let us call them as external nodes, which are representing unsuccessful search. So let us say E is the total paths of all external nodes. So sum of the paths of all external nodes. So there is some relationship between this one. If E is the sum of the paths of external nodes, then I is the sum of the paths of internal nodes, then this is always true. E is equals to I plus 2n is always true. So a small example I will take and show you. Like suppose there are 3 internal nodes. So definitely there will be 4 external nodes. Now number of nodes are 3. Now sum of the paths of internal nodes. See, the path of this one is 1. The path of this one is 1. So total path is 2. Then for the external nodes, for this the path is 1, 2. For this also 2. So there are 4 nodes whose path is 2. So this is 4 into 2, that is 8. So this E is equals to I plus 2n. So this is 2 plus this is 2 into number of nodes are 3. So this is 2, 3, 6 plus 2, that is 8. So here with an example I have proved it. Then one more fact we will take, that is number of external nodes are equal to internal nodes plus 1. So if there are 15 circular nodes, there are 16 square nodes. So number of external nodes will be 1 more than number of internal nodes. So this is another fact we will take. Now what is average successful time for n elements? So average successful search time for n elements is equals to total paths of all internal nodes divided by number of nodes. So we will get average path. And we know that for this node path is 2, but the number of comparisons are 1 extra. So for every node 1 extra comparison is there. So average path plus 1. So this gives average successful time in terms of paths of internal nodes. Then what is the average time taken for unsuccessful search? So average time taken for unsuccessful search for n elements is E by total number of nodes, average time. So total number of nodes are, we know that if n nodes are there, then external nodes will be n plus 1. So this is n plus 1. Average successful time, average unsuccessful time. Now there is one more fact that I have to highlight here, that is all these external nodes are at same height. So I can take the path as log n. So total how many nodes? N plus 1. So n plus 1 into log n. So approximately E is equal to n log n, or n plus 1 into log n plus 1 we can take, or else n log n. So how much is the time taken in unsuccessful search? This can be taken as n log n divided by n plus 1. So we can take it as approximate n plus 1 and cancel this one. So that is log n. So average unsuccessful search time is also log n. Now don't get confused that how I am dividing n by n plus 1. So that plus 1 you can ignore it, right? Approximate result we want. Directly I am cutting off n by n plus 1. See, for knowing the time complexity, we need the approximate, we need just the idea. So for that idea, we can take the approximate value. We don't have to be very accurate. So this is n plus 1. Assume that this is also n plus 1. As I said, this will be n plus 1, but we are writing n here. So n plus 1 gets cancelled. So it is log n. So average unsuccessful search time is log n. Then what about successful search time? See, from this formula, we can say that E and I are related to one another. Yes. So in this formula, I will replace E because E is how much? N log n. So let us change this formula. So here I will do workout. Average successful for n is equals to 1 plus I by n. E is equals to I plus 2n. So I is equals to E minus 2n. So this can be written as 1 plus E minus 2n by n. This can be written as 1 plus E by n minus 2. Now E, what E is? So already we know the answer, that is n log n. So this can be taken as 1 plus n log n by n minus 2. So this gets cancelled. So this is approximately log n. So average successful search time is also log n.